Hello everyone, welcome back to the next review of the Raku solutions. Now we'll take a look at the task number 1, reverse integer of week number 84. So here's the task. You're given an integer n, write a script to reverse the given integer and print the result. Print 0 if the result doesn't fit in 32-bit signed integer. This number is the maximum positive value for the 32-bit signed binary integer. What is binary integer in computing? Right, so everything is clear. Like here's an example: 1 2 3 4 becomes 4 3 2 1. If there's minus, it stays there, and if the number after being reversed is basically bigger than that big number, it becomes 0. The only thing I don't it's not quite clear from this task, what is like the negative number is above the possibilities for the 32 bits, right? So it's not like explicitly said here, but on the other side we're talking about 32 bits. So potentially if it's minus something, plus minus 1 I believe, right, then we also have to print 0. But let's look at the solutions. So let me start with my solution, and here's my solution. So what I'm doing here, I'm taking the number from command line, I take its sign, so there's the sign method, and it returns -1 or +1 or 0, depending on the sign of the number. 0, if the number is 0, you will get 0 as well, I think. And you multiply it by the absolute number flipped, right? So actually, first you take the absolute number, you get the number after that. After that, you call the flip method, which actually first converts the number to a string, flips it, and actually after that you're using this in multiplication, so it's again converted back to a number, and so Raku does that for free, and you even don't notice. And finally, if this number, obviously this number in Raku is, it's not limited to 32 bits, so we have to check it. If it goes outside the range, I also use the negative maximum, then you print 0. If it is in this range, you print R. So simple. So let me run this as Raku 1, and I will test this on this number 1 2 3 4. Probably I even have to take it to buffer. So that's -4 3 2 1, which is correct. Okay, going next. The next solution here is the solution by Feng Chang, and so here we have a couple of constants, and they are both sigilless, and right, so we take the number from the command line, we topicalize this number, and when it is 0, we print 0. If it's positive and below maximum, we print the flipped version. Also notice the fancy Unicode character less or equals. And if it's again within the borders, but on the minus or the negative side of the axis, then what you do, you just literally print a dash, a minus, to represent minus, and after that you flip the negated version. So you don't necessarily have to take apps of the number, but you can just it's the number below 0, so why not? Okay, Raku Feng Chang Raku 1 -1 2 3 4 -4 3 2 1. Next solution, Jan Krnavek gave us this solution. So what we see here, a couple of main functions. One of them is for the random number, the arbitrary number that you can type in the command line, and you call reverse integer. And actually notice that you don't have to put parentheses around this n. Raku is fine, and actually also there's no semicolon because it's the last thing before the closing curly bracket, the curly brace. And like here, for example, you have to have these parentheses because otherwise it will not be clear, because there's comma, and are you going to pass 1 or 2 arguments? Who knows? Right. Nevertheless, but actually Raku probably can decide because there's only one argument in this only function, but nevertheless. So what you do, you topicalize this value, and this value is again, so we take the sign and we take the abs and flip, right? And after, so basically, yeah, that's the task is half of the task is already done. The second half is just to check if this number is inside this range. That's really fancy style of typing this. So we see 2 powered to the power of 31, and yeah, these are the superscripts. Really nice feature of Raku. Yeah, these superscripts, they do not really look really good, but nevertheless. So we skip the last number here, so we don't have to explicitly type -1. Yeah, if it is within the range, you return it, otherwise return 0. So we can test it. 1 bash Raku 1 minus 1 2 3 4. You're right. So yeah, I will not test big numbers. It's a lot of typing, and we probably can guess if the program is working just by looking at it. Okay, Mark Anderson. Right, so unit sub main, the copy of the number. Then what we do, we already, yeah, here again, the same thing. We convert it to the flipped number, preserving the sign, and after that there's the max constant. Well, it's not constant, it's variable, sigilless. And if this number, here we're using smart match operator instead of given when, but actually in given when we're using the same smart match, right? If I'm correct. If it's within this, yeah, so here we have -1 instead of hat. Yeah. Okay, let's run this solution. Raku, Mark Anderson, Raku, 1. Right, correct. The next solution, Markus Holzer, and here is the solution. So unit sub main, right? We take the integer from the command line. Nice. So yeah, say, right. So if I is, okay. So yeah, that's an obvious thing to do, but actually that's not correct. Because if the output number is within this border, because for example, if we start with the number starting with 1 and ending with, for example, 7, then the direct version of the number is correct, is within the border, but the flipped version is not. It starts with 7, like, right, and if there are like, how many, like 9 digits, so 10 digits, doesn't matter. So yeah, so we substitute, so what we do here, so we replace all the digits with the flipped version, and we convert it to the number. Wow, why? Okay, nevertheless, Raku, Markus Holzer, Raku 1, this one minus, yeah, so definitely the result is correct, but what I mean if 1 2 3 4 5 6 7 8 9 or something like that, right? So we can flip that, and we can flip that, and we cannot flip this, but actually this number is within the maximum, right? This is 2 to the power of 31. It's already bigger, right? No, wait. This, where is, yeah, just Perl Weekly Challenge. Right, reverse integer. So where's the number? We want this number. So yeah, so this is 1 2 3 4 5 6 7 8 9 9, right? Less than this number. Oh my god. Woo! Right, and then 1 2 3 4 5 6 7 8 9. This is the number, right? Which you cannot. Right, yeah. So okay, yeah. So basically, this number you cannot already flip because the flipped version is already bigger than. Right? Yeah. Okay, good. Right, going next. The next solution by Philip Hood. We're taking the number, input number, and if it is less. Okay, so if it's less than 0, so basically that's the dot sign, right? Method, the manual implementation of that method. So then we take these apps. Notice the parentheses. Actually, they are not required, but they are fine. Then we split into digits and reverse this list, this array of digits, and we join it. So and this actually replaces the flip method. Out. If this absolute value is bigger than this one, plus minus 1 actually is missing here, right? Then 0, otherwise this one. Okay, but Raku, right, Raku Ch 1, like this one, right. Output is correct for this, at least, number. Simon Proctor, Raku number 1, gave us this solution. So the solution here takes the program takes the number, there's constant max. You see, when you have constant, yeah, no sigil is required. And the sign, again, dot sign, right? And flipped of the absolute value. And if it's bigger than max, yeah, for negative values, it's not. No, wait. Its value is already right. So everything is fine, except that I believe, right, it should be 8 here for the negative number, right? Or yeah, okay. And yeah, so we keep the sign and we put it back when we print the number. Raku Simon Proctor, Raku Ch 1 minus. Right, that's correct. Stuart Little, Raku number 1. So this, we take the number from the command line. We eval it. Why do we need to eval it? And after that we take the int. Yeah, it sounds strange, right? But nevertheless, so after that we've got this int and we pass it to the rev function, which takes, if it's bigger than this limit, absolute number is not checked here, then we return 0 as an array, and otherwise we return, well, actually it's not an array, just the expression. And after that we sign chop. Interesting. So this sign will give us plus minus 1, and if we chop one character from the back, we will just have minus if it was minus there. And after that we concatenate that minus character, the potential minus character. It potentially can be 0, empty thing, if the number is but wait, then we do not check big negative numbers there, right? And after that we flip the absolute version of that. Okay, Raku, probably I should have like create a list of test cases, but you can do it yourself as homework with all those big numbers below 0 and stuff. Right, Arne Sommer, Raku number 1. Here is the solution. So we take the number from command line, we determine the sign as the character, and this sign is concatenated to the flip version. And if, yeah, so this is the correct thing for comparing, for checking if the number is within the allowed range. We say, wow, that's wow. I would expect, say, like out in the outside thing of all these checks, but actually, yeah. Obviously, you can do it like this. Why not? Right. Raku Arne Sommer Raku Ch 1 minus. That's correct. Good. Going next. And we come to the solution by Athanasius, Raku number 1. Here's the solution. We take the number, defined number, which is integer. We take the integer of it. It is already an integer. Why? And we reverse the absolute version. Right. I don't understand if it's yeah, so it's absolute. So right, we have okay, so yeah, basically it's the copy of the input number, I believe, right? If number is, yeah, but why do we need it? If number is below 0, we multiply the result by -1, and if it's less than minimum, and if it's more than minimum, then it's 0. That's very clear. And here are the computations for getting these constant mean and max. That's correct. Right, Raku Athanasius Raku Ch 1 minus. The output is correct. Going next, Colin Crain Raku 1. So what we have here the unit submain, which takes an integer from command line with some default value, which is a good choice actually, because yeah, first of all there's minus, and second, after flipping you've got these zeros leading, so probably you should not print it actually. And actually I believe even my solution suffers from that, right? Because Raku Ash, Raku Ch 1, for example, like, yeah, okay, let's these, right? Oh no, that's correct, because I don't know why. Because there's multiplication, right? So there's multiplication, so it will remove those zeros. Okay, so here's the sign, dot sign, the emulation of the method, built-in method, and output is this sign multiplied by the flipped absolute value, right? And if it's outside, right, Raku, Colin Crain, Raku Ch 1. Yeah, let's use this built-in value, which is correct. Good. Jaldhar Vyas. Right, here is the solution. Oh, well, it's big enough. So we take the integer, we copy it, the sign, we assign the sign to 1 if the number, yeah, it's not -1, but it's 1, but like the flag that the sign is there, minus sign is there if the number is, and we negate the number for this case. Actually, yeah, you can use minus here, but yeah, probably it's as efficient as calling the method, but you can check it. If the number is bigger, again, like for negative, it should be 8 here. And by the way, notice that definitely I forgot actually, but you can use $_ to split the group of digits. We immediately print 0. Otherwise, we're trying to create the reversed number by just taking the digits one by one and dividing them. And putting them from another side of the value, right? And if there was a sign, we add this sign as a character. Raku, Jaldhar, Raku, Ch 1, minus 1, 2, 3, 4, minus 4, 3, 2, 1. Julio de Castro, Raku 1. So there's the maximum number as the constant, and there's more sigil-less things here. So the flip function takes the number, and if it's bigger than this max, okay, so we keep the sign and we flip the absolute version, but would not check if the number is like less than minus max, right? That was not clear in the task, I agree. And probably like, yeah, here is some test examples which we actually should use, right? Raku, Julio Julio de Castro, Raku Ch 1. Like everything is correct, including things which, yeah, so for big and negative, I believe it will print the flipped version, right? Kang-min Liu, Raku 1. So the program actually starts here. So for all the input arguments, we do that. We call this function, and yeah, so we just see the process n becomes flipped n, right? And the function takes the integer, and yeah, so this is the output. So here's the emulation of .sign method, flip. Okay, yeah, that's fine also. Like you don't necessarily have to call those functions as methods, but you can call them as functions. There are, yeah, actually this is the feature Raku. So that's the feature of Raku for many functions like that, flip, sum, and all that. There are two things defined in language as so this flip exists as a subroutine, and it exists as a method, so which is really good, right? And yeah, and if this is within the range, we print it. And again, we're using both Unicode here and those superscript characters here. Raku Gug, Raku Ch 1 minus, oops, note, minus 1, 2, 3, 4. Yeah, so this number becomes that number. Going next, Laurent Rosenfeld, Raku 1. So here's the, there's no syntax highlighting. Right, so what we have here, so here we have maximum number, definitely. Input, we take it from the input, positive, basically it's the flag. If the input is less than 0, we set this flag to false. Why? Yeah, it's positive is false, okay. And we negate, so here we use minus, the prefix operator, right? And otherwise, well, after that we flip it, which is already positive number, and if output is bigger than maximum and it is positive, then we print 0. If okay, so we're still working with positive numbers only, right? Because we put additional minus here, and actually this is just this is the prefix operator that converts the string to a number, right? But probably it's not needed because we'll just print it. Okay, nevertheless, but that's good. Raku, Laurent Rosenfeld, Raku 1, and this input number, this same input number, which gives the correct result. Good. Okay, going next. Myoungjin Jeon, Raku 1. Yeah, that's probably, wow, the biggest solution. Let's see what's there inside. RD export needed to use globally. Is export, what are we going to export? Okay, so the main function, multi-main, why is it multi if it's the only one? When side effect, when you use multi with main, even though it has a main declared, Raku gives a simple help message with invalid. Oh, really? That's cute. Okay, so we take the number and filter 32 bits, solution chain. Wow, that's too difficult, I believe. Right, so what's this filter is about? Okay, so this is probably the most straightforward function that we need. So reverse integer, we take the integer and we return the string. Oh, that's cute. Like there's a list of a couple of values, and we subscript it with this sign, and we take the sign as the integer version of the Boolean comparison. Right, so if it's less than 0, it's true, and we get 1 here, the first index. If it's bigger than 0, or if it is 0, then it's false, and it gives us 0, and we take the first thing of here. So that's an interesting thing, not necessarily a required thing, but an interesting approach. Right. And we concatenate that to flipped version. Basically, that's the thing that the program actually does. So solution change, filter 32 bits, and after that, ref int. And actually, it's not the function call; it's the reference to the function, which is potentially, which is used, just like the word potentially today, which we are using here to do something. Right, so here, I already forgot what's that. It's like when you call the function after function of the function, right? And so so we have this app chain. For example, we start with these two functions, and basically we call the first function, and the result of this function we pass to the second function, and the first function gets this n as the argument, right? If I understand this correctly. So basically, here's the extended thing of that. We had this sign, this circle operator somewhere like a few weeks earlier. A really interesting thing. Okay, so we have. Right, so speaker, what is speaker? So we have this application chain, and basically we apply the functions one by one and filter 32 bits. Probably, it filters the thing. Assume this is a 32-bit machine, so this routine will get reverse string with signed prepended and compare it with limit value as string. So there are some calculations, and but so we apply the role here, but 0, less true, same, more, Yeah, okay, somehow, but I believe it works, right? So Raku, yeah, so let's go to the solution. Raku Jeon, Raku Ch1, right, so minus 1, 2, 3, 4 gives us the correct result. 5, 6, 7, 8, 9, 9, 0. That's correct. Okay, right. Going next. Next is the solution by Roger Bell West, Raku number 1. So here's the solution. There are 3 test cases. RI stands for reversed integer, I believe, integer in the input, and we comb, so we split into digits, then we revert them, and we join them. Actually, minus after this will appear on the right side of the number, right? If R, it's not much, well, yeah, basically regex, if, okay, yeah, so if there are some numbers followed by a minus, which is at the end of the line, then we, yeah, okay, so we extract the number here and append as a string. Actually, the string can string interpolation. We append this minus there. That's probably how we can check if the number is there. So you convert explicitly this integer and you try to put it to the int32 native variable, and yeah, I believe actually if there are any checks, if the number int32, if the number can be put into there, probably not, right? So native size, but I like this check. I like this. So, and if after this conversion, yeah, definitely after this conversion, we'll already will implicitly ask Raku to convert the number back to an integer, capital integer. But if the number is different, if it differs after putting it into the native int32 variable, then it's 0. That's very cute, right? Okay, Raku, Roger Bell West, Raku Ch 1, minus 1, 2, 3, 4. Okay, 5. Ah, yeah, it's ignored. Okay, but this one, when flipped, yeah. But so yeah, this is cute, right? Okay, probably we can even do it like in a single go, right? Yeah, but there's no, you cannot do it as an operator, right? Yeah, I wanted to write it in a single line. Probably it's possible, but not necessarily it is required. Okay, good. And finally, the solution by Ulrich Rieke, Raku number 1. So here's the solution. Let's syntax highlight it. So we take the string from the command line. We extract the sign, potentially actually the plus sign is there, and the numbers. So the max number. Again, from negative numbers, it doesn't work. So n is already the positive part, well, the digits, the digital part of the number. And if it's less than number, then we do something. Otherwise, we return 0. We print 0. And here, so we take $0, the sign, convert it to a string, and we append it to this one, right? What if the number is negative and big? This one will give us, because this is just a check against the regular expression, and here is the original number, so it can be minus very big number, right? And it still will be less than positive maximum. So yeah, for we do not check if the output number is below the negative range, right? Negative edge. And we flip. Okay, right. So yeah, Raku. Who was that? Ulrich Rieke. Raku Ch1, 1, minus 1, 2, 3, 4, 5. Yes, that's correct. And that was the last solution in this list of the solutions of week number 84, task number 1. We were reversing the integer, well, flipping the integer digits. Right. So see you next time.